Please write this down. This is very important. Whenever there is a competition between substitution and elimination reaction, correct? The reactivity order of the alkyl halides usually vary in this manner. Please see this very carefully. Are you all with me? I need 500% attention. Yes, even if you've missed something so far, that's well and fine. But now what I'm going to tell you is most crucial, because basic things you have been seeing it. All the students in all the world, they go through it. They miss out here and there, that's fine. By basics, they know what is SN1, SN2, E1 and E2. But the questions don't come from that basic. Questions come from the gray area where there is confusion. Where will E1 happen? Where will E2 happen? Where will SN1 happen? Where will SN2 happen? How do I choose it? I hope it is clear. Yeah. So we are in that discussion of gray zone. One of the most important, crucial zone of the whole of organic chemistry. Yes, interesting. So we'll proceed from the elimination reaction, dehydrohalogenation. Beta elimination cases we have already seen. When you use alcoholic KOH, correct? Beta elimination will take place. In that beta elimination, you will have this is the alpha carbon, this is the beta carbon. The beta carbon's hydrogen will be snatched away. That electron will be utilized for, let's say, one hydrogen is this side, correct? So this hydrogen will be snatched away. This electron will be utilized for forming a double bond, and as soon as double bond formation happens, what will happen? X minus will leave. Is that clear? Correct? Yes, that H plus which has left, that H plus will combine with this X minus, forming HX, and you will have the elimination. Elimination product is, you will have the alkene ready. Elimination product is most of the time an alkene only. Yes, apart from the other minor product. Another example. Yes, this time you will have a butene as the major product. That doesn't mean that butene formation will not happen. That also is highly possible. Why? Because this time we have two beta hydrogen carbons, and similarly more beta hydrogens. This side 2 beta, this side 3 beta hydrogens. Yes, so attack can happen either from here or from here. This side one will be the major product. I hope it is clear. Yeah. Then we also saw the difference between E1 and E2 and all that. I hope you remember that. Yes, when the competition happens, this is very important. Let me mark it as very, very, very important, this section. Please write this down. This is very important. Whenever there is a competition between substitution and elimination reaction, correct? The reactivity order of the alkyl halides usually vary in this manner. Please see this very carefully. Are you all with me? I need 500% attention. Yes, even if you've missed something so far, that's well and fine. But now what I'm going to tell you is most crucial, because basic things you have been seeing it. All the students in all the world, they go through it. They miss out here and there, that's fine. By basics, they know what is SN1, SN2, E1 and E2. But the questions don't come from that basic. Questions come from the gray area where there is confusion. Where will E1 happen? Where will E2 happen? Where will SN1 happen? Where will SN2 happen? How do I choose it? I hope it is clear. Yeah. So we are in that discussion of gray zone. One of the most important, crucial zone of the whole of organic chemistry. Yes, interesting. Let's do that. So what do we learn from here? Whenever these are all degrees, 1 degree, 2 degree, 3 degree alkyl halides. Yes, we know E1 reaction will happen. 3 degree alkyl halides will be most preferable. Yes or no? Highest reactivity will be there for that. E2 also same 3 degree alkyl halides. Yeah. SN1 also same 3 degree alkyl halides. I hope it is clear. Yeah. Only when it comes to SN2, 1 degree alkyl halide will have the highest reactivity order. Yes, this table will give you even better idea. Let's see this carefully. I hope you're with me. Yes, you're with me. Let's focus on this table. Very important. What are we doing here? When you talk about alkyl halides, yes, they mainly give substitution unless sterically hindered alkyl halide or sterically hindered base, in which case elimination will be favored. When there is a choosing going on between SN2 and E2, possible na? Yes or no? Choosing going on between SN2 and E2, alkyl halides will mainly give what? Substitution product. Unless until you have a very huge sterically hindering alkyl halide either present there or the attacking base, or you can actually it is the base only who behaves as a nucleophile. Yes or no? In case of SN1, SN2, it behaves as a nucleophile. In case of elimination, because it is taking away hydrogen, it behaves as a base. Its natural state. Correct? Correct? It's actually a base who behaves like a nucleophile. I hope it is clear. That confusion is not there so far. So that base is going to behave as a nucleophile in SN2, but as a base in E2. But the question here is where it will behave how? Unless until there is a sterically hindered, very huge, bulkier base. Correct? Correct? Then you know in SN2 which is most reactive? 1 degree alkyl halides. Then what will happen? If it is sterically hindered, E2 formation will happen. Is that clear? Is this part clear? So mainly gives a substitution unless there is sterically hindered alkyl halide. Either alkyl halide is a tertiary alkyl halide, yes, then E2 will undergo, or the base which is attacking either in the form of nucleophile, correct? That sterically hindered, that base is also too huge or sterically hindered. In that case, what will happen? Elimination will be favored. I hope this part is clear. In that case, elimination will be favored, otherwise substitution. Good. Out of SN2 and E2. Yes, correct. But if we have to choose between SN1 and E2, it cannot undergo SN1 or E1. Is this clear? It cannot, sorry, it should be 1. Do the correction, it should be 1. It cannot undergo SN1 or E1. Either SN1 or E1. We are talking about 1 degree alkyl halides. Yes, 1 degree alkyl halides, the chances of SN2 happening is highest. I hope that part you have learned so far. Yes, I'll repeat once again, focus. 1 degree alkyl halides, the chances of SN2 happening is highest, but elimination product may still form. That too, which type of elimination? E2 elimination. We know E2 elimination can happen in case of 3 degrees or even in case of 2 degrees also. Only and only when we have, in case of 1 degree alkyl halide also it can happen, provided if the alkyl halide is not that sterically hindered, if the attacking base is sterically hindered, huge in size, then only nucleophilic SN2 will not happen and E2 will happen. Are we clear? There is no way chances of SN1 or E1 happening, because both of them strongly are preferred by 3 degree alkyl halides. Is this clear? Yes, beautiful table, very important table. I hope everybody can understand this part. Let's move to the second part. Now we go to the 2 degree alkyl halide. Yes, in the middle. This 2 degree alkyl halides, both chances are there. Both substitution as well as elimination, provided we have a stronger base or a bulkier base or a high temperature, greater percentage of the elimination will happen. Yes, that means we'll have substitution product also, elimination product also. stronger base, bulkier base, or high temperature. If these things are there, then there will be major product will be an elimination product. Is this clear? Yes. Is this clear? Please keep in mind high temperature. More of E2 will form rather than SN2. Correct? And 2 degree is kind of in the middle. It's like the boundary. The most moderate reactivity order of reactivity is for 2 degree, and that is there in all the cases. So SN2 also product can also form, E2 product can also form. E2 will form when there is higher temperature or bulkier base or basically stronger base. Yes. Yeah, another thing, when it was written here sterically hindered base, you should also consider a stronger base. Yes, stronger base can do that. Somewhere oxygen and all is present. You're getting my point? Yeah, methyl oxide. CH3OH is there, so that oxygen, or so anywhere OH minus is there, that is a stronger base, isn't it? Yeah. Okay. Then similarly, either SN1 or SN or E1 also can form. Why? Because 2 degree is in the middle, is the boundary fellow. Yes or no? Similarly, SN1 and E1 also can form both substitution and elimination product. That means SN1 and E1 products can form, provided if there is high temperature, there will be greater E1 product. Simple? Simple boundary line fellow. So highly likely chances of either SN2 or E2 or SN1 or E1. Yes, only elimination product chances are more when we have some stronger base or bulkier base or higher temperature. Temperature plays major role here. Good. Let's jump on to the 3 degree alkyl halide. 3 degree alkyl halide, you know what does it undergo mainly? Which out of 4, which highly likely chances are there? Elimination. Do you see that? Highly likely chances of elimination are there because either E1 or E2 it will happen. Elimination way only. Yes or no? Yes? Okay. When it comes to SN2 and E2, comparing SN2 and E2, no way SN2 will happen. Yes or no? No way SN2 will happen. If we are comparing between these two, no way SN2 will happen because SN2 has the least reactivity order for 3 degree alkyl halide. So what will form here? E2. Are we good? Yes. But here, when we compare SN1 or E1, both are highly likely equal to have equal probability, provided again which type of base you are using. If you're using a high temperature or if you're using a stronger base, then they will be major product as elimination product, same as the above one. Yes, because SN1 and E1 are kind of having same reactivity order for 1, 2 and 3 degree alkyl halides. Yes, is this clear? Now let's once again write down on the side what chances are more in short. When we use 1 degree alkyl halide, what chances are more out of SN2 and E2? Obviously SN2. Yes or no? 1 degree alkyl halide, most reactive. Yes, SN2 chances are there, but you know there are chances of E2 also. Special cases. I am writing special case, and that special case, you understand what is that special case. What is the special case? Tell me.
Sterically hindered or strong base.
Strong base or huge base. In short, I am writing. Yes, sterically hindered is huge in size, or sometimes even high temperature also. Keep that in mind. All three chances are there. That is your strong special case. Let me make the thickness smaller. I hope it is clear. Yeah? Good. Here what will happen? SN1, E1, neither. Neither of it will form. Yes or no? Chances of SN1 is not there at all because both of them have least react. Actually, 1 degree alkyl halides has least reactivity in all these cases, E1, E2 as well as SN1. SN1, E1 chances are not there. If 1 degree alkyl is there, either SN2 will form or in rare cases E2 will form, provided the base is all this. Make sense? Yeah. Let's write down in case of 2 degree. In case of 2 degree, either of it will can form SN2 E2, equally likely case. Yes or no? Either SN2 or E2. Is this clear? Either SN2 or E2. In which case E2? When we have special case. E2 in special cases. Good. Similarly here, either SN1 or E1. But in which case E1? In case of special case. And that special case I have discussed here. Yes or no? What is that special case? Either you have a strong base, yeah, or you have some sterically hindered huge size base, or the temperature is very high. Basically any extreme conditions. Understood? Similarly, when 3 degree alkyl halides come, then you will have E2 and E2 alone when it compares to SN2 and E2. Yes, 3 degree alkyl halides, you will have E2 chances more, because what are we comparing in this case? SN2 and E2. SN2 least reactivity for 3 degree alkyl halides, E2 highest reactivity for alkyl halides. Obviously E2 will have. Yes or no? Yes. Is this part clear? Yeah. Let me remove this, erase this so that we can see this better. Okay. Fine. Similarly, in this last case, SN1 E1, same way, either SN1 can happen, exactly same thing is going to get followed here. So I'm just making this sign, or do. Either SN1 or E1 will happen. Chances of E1 is more when we have high temperature or extremely strong base or sterically hindered base. Are we good? Now this clears off all our doubt about where SN1, SN2, E1, E2 will happen. Yes? Please mark it as very, very important. This section is going to remove all your confusion. The questions will not come just plain and simple in a dry way from where? From where? Just what is E1 and E2? Questions will come from these gray areas. Yes, I hope I have resolved your doubt. Shall we proceed? Some more important note points as an example to understand it better. Let's see here. What is that? SN2 or E2 will be favored by high concentration of good nucleophile or a strong base. Who are those? I already told you, wherever there is hydroxide ion or either OH minus or OR minus. These are considered to be strong bases. Yes, or stronger nucleophiles. In such cases, chances of SN2 or E2 is there, provided if it is 1 degree alkyl halide, more likely chances of SN2. If there is 3 degree alkyl halide, more likely chances of E2. Remember, here there is more chances of SN2. Here there is more chances of E2. I hope it is clear. In rare cases, E2 also can form here, but for that, the base has to be very big in size. Most of the time, they are not. Are we good? Yes. When it comes to SN2 and E2, the rate of the reaction depends upon not just the initial substrate or the reactant, not only on the concentration of initial substrate or reactant, it also depends on the concentration of the reagent. That means our base, this very base. Yes or no? This very nucleophile. Rate of the reaction is proportional to, because it is both of them are bimolecular, na? SN2, E2, bimolecular. So it will depend on the concentration of substrate as well as reagent. That's why The base or the nucleophile plays a major role. Understood? Yeah. Okay. But when it comes to SN1E1, does the rate depend on the concentration of the nucleophile? No. It is favored, in fact, by low concentration. Here it is favored by high concentration. Yes or no? That's why we were saying that stronger base and all that. Yes, it is favored by, in fact, low concentration SN1 and E1 of which type of nucleophile? In fact, a poorer nucleophile, not that strong nucleophile, or a poorer or a weak base. Now, who all will be weak base? Add one H plus to these fellows. OH minus is a strong base, but add H plus, what does it become? Water. Water is a weak base. In fact, it is a weak acid as well as a weak base. That weak it is. Almost at a boundary line. Yes or no? Yes. Similarly, ROH is a weak base. Make sense? See, little change and the whole thing flips. In case of SN2E2, if these two fellows are there, chances of SN2E2 will be there, provided 1 degree and 3 degree alkyl halides are being formed respectively, because SN2 in case of 1 degree alkyl halides, E2 in case of 3 degree alkyl halides. In case of SN1 even, poor concentration of some or less concentration, low concentration of some poor nucleophile or weaker base should be there. That's where these fellows come in play. Yeah. Last point, but very important. Please see this. If an alkyl halide undergoes either SN2 or SN1 reaction, then SN2 will be favored by high concentration of good nucleophile, which is negatively charged, in the presence of polar aprotic solvent. Tell me, what do you mean by aprotic solvent and protic solvent? Come on. What do we mean by aprotic solvent and protic solvent? Come on, Risha.
The ones that dissolve to give protons or H plus will be protic solvent.
Give me example.
H2O can split as H plus and OH minus.
So who is the aprotic solvent here?
No, sir, it's a protic solvent because it's giving an H plus.
Obviously, aprotic means the one who is not giving. Protic means who has proton. Correct? The acidic hydrogen. Is this clear? Aprotic solvent does not have the replaceable hydrogen or the acidic hydrogen atom present in it. Simple. Correct? What are we looking for here? Here do we have replaceable hydrogen? See here. You see for yourself. Remember these two fellows, these two examples. The easiest one, in fact, this what I have written is much more easiest. OH minus or OR minus, do they have the replaceable hydrogen with them? Talk to me. No, they don't have. Yes or no? They are aprotic. At the same time, they are polar in nature. That is where it is written SN2 is favored by whom? First thing first, high concentration. Let me change the color. Yeah, first thing first. One second. First thing first, high concentration. Correct? Next, a good nucleophile. This was point number 1. Point number 2, good nucleophile. Point number 3, which type of solvent? Good nucleophile or strong base. Correct? Since we are comparing only SN2 and SN1, so I'm not telling base in that case. Yes. So high concentration, good nucleophile. Yes. At the same time, which type of base? Then see these fellows. They are aprotic in nature. At the same time, they are polar aprotic solvents. Nice. Write down all 3 conditions. 1, 2, 3 in your notebook. For what? SN2 to happen. What was the first condition? High concentration of good nucleophile. Yes. Correct? In polar aprotic solvent. In bracket, write down your OH minus, OR minus. Are we clear? At the same time, these fellows, they are protic solvents. They have the replaceable acidic hydrogen present in them. Yes or no? Yeah. ROH or water, they have replaceable hydrogen. So SN1 will be favored when? When will SN1 will be favored? Write that down also. First case, low concentration. Is that clear? Low concentration of what? Second point, a poor nucleophile. Yes or no? Yes. And third, polar. Since they are still polar, water is polar now. Water alcohol. Yes, they are polar. Wherever oxygen is present, there is presence of permanent dipole-dipole situation. So they are polar in nature. Yes, polar but protic. They have replaceable acidic hydrogen present in them. Polar protic solvent. An example, your water or alcohol, etc. Why am I giving these two examples? Easy to remember. Yes, this completes all the details about where what will happen. If there is only confusion between SN1 to SN1 and SN2, that is cleared here and here. If there is only, and if there is confusion between SN2 E2 or SN1 E1, that is covered here. And that too for all the cases of 1 degree alkyl halides, 2 degree alkyl halides, 3 degree alkyl halides. Yes or no? For all the cases of 1 degree, 2 degree and 3 degree alkyl halides, whether it is either SN2 E2 or SN1 E1, that part is discussed, or it is between SN2 and SN1, that is also discussed. Yes, if you are not able to understand the table, at least understand point number 1, point number 2, point number 3. Point number 1 compares SN2 E2. Point number 2 compares SN1 E1. Yeah, but point number 1 and 2 doesn't tell you when SN2 will happen, when E2 will happen. For that, we need to know what type of alkyl halide is also present. So individually they are discussed in this table. Yes, now it has become too much. Let me refresh it. Yeah. I hope you'll be able to see it now much more clearer. Let's come down. Very important section, na? That's why so much of writing. Yeah. Good. I hope it is clearer now. Yes. Everything is cleared. Everything is understood. No more confusion, I guess. Once again, to give you in short the detail, you have understood the reactivity order. The basic reactivity order is clear to you. Yes. Once the basic reactivity order is clear to you, then the question arises, who will undergo which type of, if you're comparing alkyl halides and there is comparison between SN2 and E2, one thing we know that they need high concentration, good electrophile or a stronger base for SN2 or E2 to happen. But if the base is hysterically hindered, very big in size, or even the alkyl halide is not, because it is 1 degree alkyl halide, but if still there is some heavy group present there, chances of E2 is there, otherwise SN2 highly likely. Yeah. Yes. Similarly, in case of SN1 and E1, this correction I told you to do, this is E1. If there is confusion between SN1 and E1, in one case of 1 degree alkyl halides, no way, neither SN1 nor E1 will form. Good. Similarly, let's see the other extreme 3 degree alkyl halides first. Here the chances of E2 is highest. Good, because 1 degree alkyl halides, the highest reactivity order is found in case of 1 degree alkyl halides only. So SN2 will happen there. Here E2 will happen. Are we clear? Who will find what will happen here? E2 will happen. But similarly, in this case, SN1 or E1, both chances are there, because 3 degree alkyl halides has the highest reactivity in case of SN1 as well as E1. But yes, for what? But yes, for what? E1 can happen more if there is high temperature. That means special cases. either high temperature or very strong base or very bulkier base and all that. Good? Good. At the same time, when it comes to these middle rows, either of it can happen. Either SN2 or E2 here. Similarly here, either SN1 or E1. But elimination products chances are more if we go for bulkier base or stronger base or higher temperature. Similarly here also higher temperature. Are we good? Yes. We also learnt about which type of solvent favors whom. But solvents play major role where? They play major role in case of SN2 and SN1 comparison. Yes. In case of SN2, we need to have polar aprotic solvent. In case of SN1, we need to have polar protic solvent. Same way, in case of E2, we have already seen that, isn't it? In case of E2, we need to have polar aprotic solvent. In case of E1, we need to have polar protic solvent. Are we good? Yes, let's take the examples of what are these polar protic, polar aprotic solvents. The most famous ones, as we already saw, polar protic solvents are water, alcohol, even formic acid. But one of the most famous aprotic solvents are DMSO. What is the full form? Anybody knows? DMSO full form? Come on, Risha, you must know. We have seen it there in GOC, back in GOC also. Nobody? Come on. Really? Should I give hint? Dimethyl? Sulfonyl oxide. Dimethyl sulfonyl oxide. Write down. Are we clear? Or in short, sometime also called as dimethyl sulfoxide. Dimethyl sulfoxide. This is more famous name. Dimethyl sulfoxide. What is happening here? Sulfur is there in the middle, two methyl groups on both the sides, one CH3 here, one CH3 here, and you have sulfur in the middle which is connected to oxygen. Is this clear? Makes sense? Understandable? Yeah? Two methyls on both the sides, that is what is your DMSO. So all these type of scenarios, correct? Even in case of CH3CN or in case of ether, correct? Or even case of thioether, all those cases are the ones where they don't have oxygen is not directly connected to an H+. Do you see oxygen connected here to H+? Any of the, in case of cyanide, you don't have oxygen, but nitrogen is there. Yes or no? Yes, an electronegative element is present there, but is it directly connected to hydrogen? No. No acidic hydrogen presence is there in case of polar aprotic solvent. They all are still polar, but they are aprotic. Got it? Is this part clear? Good. Let's move to the next part. Some examples are shown here. What do we have here? Propyl bromide. And what are we using? This is polar protic, polar aprotic. What is it? Polar protic, polar aprotic. Come on.
Polar
Fast.
aprotic.
Polar aprotic. So what chances are more, SN2 or SN1? SN2 product will have the major product. Is this clear? Apart from that, SN1 chances are still lesser, but E2 elimination product can form, but that will be the minor product. Why? Because your base is not that bulky. Are we clear? Yes, it's not that bulky. Neither your alkyl halide is that bulky. Correct? Make it bulky. Let's take 2-degree alkyl halide, or basically a secondary alkyl halide. Yes or no? Now use the same base, which is stronger base. Yes or no? At the same time, is polar aprotic. This time your SN2 becomes a minor product. Can you see that? Nice. In one example, everything is clear. Who is the major product? Your elimination product is the major product. Examples help much more than the theory. But if you don't tell the theory, you cannot relate it with the example. Yes or no? Yeah? Nice. In this example, you understood that there is no one bulky here. That's why SN2 is the major product. Yes. But in this case, you saw that since there is at least a bulkier alkyl halide, SN2 becomes the minor product, but E2 becomes the major product. Nice. Another, take much more bulkier. What will happen? Take much more bulkier. Only elimination product will form. In fact, this becomes E1. Because on its own, Br minus will leave. Yes or no? No need of the base to come in vicinity. So it becomes E1. Elimination products dominates. Nice. Is this clear? Pardon me. Next part. Take a straight chain and this time make the base itself bulky. But which type of base is it? Is the oxygen connected to a acidic replaceable hydrogen? Check. Is it aprotic or protic? Aprotic. Oxygen is not connected to a hydrogen. Aprotic solvent. Yes. Now if bring this bulkier fellow here, obviously what formation will happen? Elimination product. Yes or no? Yes. But which type of elimination? Because this is 1 degree alkyl halide. Which type of elimination? E2 or E1? Come on. E2 or E1?
E2.
E2 formation will happen. This is your major product. E2 mechanism. Yes or no? I hope it is clear. Everyone understood what's happening here? Any confusion? With the help of these 4-5 examples, I hope everything is cleared. Yes? Once again, let me show you. If 1 degree, but a strong polar aprotic solvent is used, yes, what will happen? As well as a strong nucleophile is being used, what will happen? SN2 will be the major product. Make the alkyl halide bulkier, SN2 becomes minor, elimination E2 becomes major. If you make it 3 degree alkyl halide, in fact, no bimolecular case. Elimination will be the most major reaction happening here, but E1, correct? But if you take the base as bulkier, still going ahead with the 1 degree alkyl halide, the comparison will be between SN2 and E2. Yes, E2 will happen. What do we have here? 2 degree alkyl halide. Yes or no? 2 degree alkyl halide is there here. Now in case of 2 degree alkyl halide, if we are choosing this fellow as a base, C2H5O minus, what will happen? Elimination product will happen. Yes or no? Elimination product chances are there. That will be our major product. Everybody agrees? Yes. But if you use, rather than ethoxide, correct, ion, what are we using? Acetate ion, CH3COO minus. If you go for that, what will happen? The major product will be this CH3COO minus will go and attach there. That will become your major product. That means not elimination, substitution happened. SN2. Who substituted whom? Acetate ion substituted bromide ion. Here, E2. Are we good? Sangvi, is it making sense? What about you, Mino? Is it making sense? Okay. Yes. Let's see now case of 3-degree alkyl halide. If you have a 3-degree alkyl halide as here, yes, and if we are treating it, let's say, a weak nucleophile, weaker base, now whose chances will be there? Either SN1 or E1. But since this is 3-degree alkyl halide, now you tell me what will happen. SN1 will happen or E1 will happen? 1-degree alkyl SN1 will happen or E1 will happen? SN1 is happening here. Is this clear? Correct? Either in case of water or in case of CH3OH, SN1 formation happening. Who is substituting in this case? OH. In this case, OR minus. Substituting what? Bromide ion. You have SN1 mechanism happening. If and only if you go for concentrated hydroxide ion or concentrated methoxide ion or any alkoxide ion or some stronger bases, correct, like CH3 triple bond C minus or NH2 minus or CN minus, these are all compared to be stronger bases. I hope it is clear. If you go for these fellows, then there are chances of E2 happening because they are concentrated or stronger bases. You remember wherever stronger bases come into picture, correct, and you have a bulkier alkyl halide, in that table we are in the bottom left now. Go to that table. We are in the bottom left now. Yes or no? Let me show you once again. We are where? We are here. 3-degree alkyl halide. At the same time, stronger bases. E2. Stronger or concentrated bases. Yes. Here we have E2 product right here in front of us. Elimination product. Is this clear? Okay. You already remember when it comes to elimination Sedgwick rule, and what was the counterpart of the Sedgwick rule? Who knows? What was the counterpart of the Sedgwick rule? Like kind of anti-Sedgwick rule? Hoffman's rule. Very good. So Sedgwick rule is that the dehydrohalogenation of an alkyl halide results in the preferentially in the production of more alkylated alkene, more stable alkene will be formed. Yes, which is more substituted. That one will be formed. That is what is being followed here. Fine. With this, we are done with all the confusion of SN1, SN2, E1, E2.